Chapter 20, Part 2 of The Voyage of the Beagle. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Joseph Ugaretz. The Voyage of the Beagle by Charles Darwin. Chapter 20, Part 2. Keeling Island Coral Formations. A few miles north of Keeling there is another small atoll, the lagoon of which is nearly filled up with coral mud. Captain Ross found embedded in the conglomerate on the outer coast a well-rounded fragment of greenstone, rather larger than a man's head. He and the men with him were so much surprised at this that they brought it away and preserved it as a curiosity. The occurrence of this one stone, where every other particle of matter is calcareous, certainly is very puzzling. The island has scarcely ever been visited, nor is it probable that a ship had been wrecked there. From the absence of any better explanation, I came to the conclusion that it must have come entangled in the roots of some large tree. When, however, I considered the great distance from the nearest land, the combination of chances against a stone thus being entangled, the tree washed into the sea, floated so far, then landed safely, and the stone finally so embedded as to allow of its discovery, I was almost afraid of imagining a means of transport apparently so improbable. It was therefore with great interest that I found Chamisso, the justly distinguished naturalist who accompanied Kotzebue, stating that the inhabitants of the Radak archipelago, a group of lagoon islands in the midst of the Pacific, obtain stones for sharpening their instruments by searching the roots of trees which are cast upon the beach. It will be evident that this must have happened several times, since laws have been established that such stones belong to the chief, and a punishment is inflicted on anyone who attempts to steal them. When the isolated position of these small islands in the midst of a vast ocean, their great distance from any land, excepting that of coral formation, attested by the value which the inhabitants, who are such bold navigators, attach to a stone of any kind, Footnote 7. Some natives carried by Kotzebue to Kamchatka collected stones to take back to their country, and the slowness of the currents of the open sea, are all considered, the occurrence of pebbles thus transported does appear wonderful. Stones may often be thus carried, and if the island on which they are stranded is constructed of any other substance besides coral, they would scarcely attract attention, and their origin at least would never be guessed. Moreover, this agency may long escape discovery from the probability of trees, especially those loaded with stones, floating beneath the surface. In the channels of Tierra del Fuego, large quantities of drift timber are cast upon the beach, yet it is extremely rare to meet a tree swimming on the water. These facts may possibly throw light on single stones, whether angular or rounded, occasionally found embedded in fine sedimentary masses. During another day I visited West Islet, on which the vegetation was perhaps more luxuriant than on any other. The cocoa-nut trees generally grow separate, but here the young ones flourished beneath their tall parents, and formed with their long and curved fronds the most shady arbors. Those alone who have tried it know how delicious it is to be seated in such shade, and drink the cool, pleasant fluid of the cocoa-nut. In this island there is a large bay-like space composed of the finest white sand. It is quite level, and is only covered by the tide at high water. From this large bay smaller creeks penetrate the surrounding woods. To see a field of glittering white sand representing water, with the cocoa-nut trees extending their tall and waving trunks around the margin, formed a singular and very pretty view. I have before alluded to a crab which lives on the cocoa-nuts. It is very common on all parts of the dry land, and grows to a monstrous size. It is closely allied to, or identical with, the Birgos latro. The front pair of legs terminate in very strong and heavy pincers, and the last pair are fitted with others weaker and much narrower. It would at first be thought quite impossible for a crab to open a strong cocoa-nut covered with the husk, but Mr. Leask assures me that he has repeatedly seen this effected. The crab begins by tearing the husk, fibre by fibre, and always from that end under which the 3 eye-holes are situated. When this is completed, the crab commences hammering with its heavy claws on one of the eye-holes till an opening is made. Then, turning round its body by the aid of its posterior and narrow pair of pincers, it extracts the white albuminous substance. I think this is as curious a case of instinct as ever I heard of, and likewise of adaptation and structure between two objects apparently so remote from each other in the scheme of nature as a crab and a coconut tree. The Birgos is diurnal in its habits, but every night it is said to pay a visit to the sea, no doubt for the purpose of moistening its branchiae. The young are likewise hatched, and live for some time on the coast. These crabs inhabit deep burrows, which they hollow out beneath the roots of trees, and where they accumulate surprising quantities of the picked fibers of the coconut husk, on which they rest as on a bed. The Malays sometimes take advantage of this, and collect the fibrous mass to use as junk. These crabs are very good to eat. Moreover, under the tail of the larger ones there is a mass of fat, which, when melted, sometimes yields as much as a quart bottle full of limpid oil. It has been stated by some authors that the Birgos crawls up the coconut trees for the purpose of stealing the nuts. I very much doubt the probability of this, but with the pandanus, footnote 8, see Proceedings of Zoological Society, 1832, page 17, the task would be very much easier. I was told by Mr. Leask that on these islands the Birgos lives only on the nuts which have fallen to the ground. Captain Moresby informs me that this crab inhabits the Chagos and Seychelles groups, but not the neighboring Maldiva archipelago. It formerly abounded at Mauritius, but only a few small ones are now found there. In the Pacific, this species, or one with closely allied habits, is said to inhabit a single coral island north of the Society group. Footnote 9, Tyerman and Bennett, Voyages, etc., Volume 2, page 33. To show the wonderful strength of the front pair of pincers, I may mention that Captain Moresby confined one in a strong tin box which had held biscuits, the lid being secured with wire, but the crab turned down the edges and escaped. In turning down the edges, it actually punched many small holes quite through the tin. I was a good deal surprised by finding two species of coral of the genus Millepora, M. complanata and Alcicornis, possessed the power of stinging. The stony branches or plates, when taken fresh from the water, have a harsh feel, and are not slimy, although possessing a strong and disagreeable smell. The stinging property seems to vary in different specimens. When a piece was pressed or rubbed on the tender skin of the face or arm, a pricking sensation was usually caused, which came on after the interval of a second, and lasted only for a few minutes. One day, however, by merely touching my face with one of the branches, pain was instantaneously caused. It increased as usual after a few seconds, and remained sharp for some minutes, was perceptible for half an hour afterwards. The sensation was as bad as that from a nettle, but more like that caused by the Physalia, or Portuguese man-of-war. Little red spots were produced on the tender skin of the arm, which appeared as if they would have formed watery pustules, but did not. M. Coy mentions this case of the Millepora, and I have heard of stinging corals in the West Indies. Many marine animals seem to have this power of stinging. Besides the Portuguese man-of-war, many jellyfish, and the Aplysia, or sea slug, of the Cape de Verde Islands. It is stated in the Voyage of the Astrolabe that an actinia, or sea anemone, as well as a flexible coralline allied to Sertularia, both possess this means of offense or defense. In the East Indian Sea, a stinging seaweed is said to be found. Two species of fish of the genus Scarus, which are common here, exclusively feed on coral. Both are colored of a splendid bluish-green, one living invariably in the lagoon, and the other amongst the outer breakers. Mr. Leask assured us that he had repeatedly seen whole shoals grazing with their strong bony jaws on the tops of the coral branches. I opened the intestines of several, and found them distended with yellow calcareous sandy mud. The slimy, disgusting Holothuriae, allied to our starfish, which the Chinese gourmands are so fond of, also feed largely, as I am informed by Dr. Allen, on corals, and the bony apparatus within their bodies seems well adapted for this end. These Holothuriae, the fish, the numerous burrowing shells, and nereidous worms, which perforate every block of dead coral, must be very efficient agents in producing the fine white mud which lies at the bottom and on the shores of the lagoon. A portion, however, of this mud, which when wet resembled pounded chalk, was found by Professor Ehrenberg to be partly composed of siliceous shielded infusoria. April 12th. In the morning we stood out of the lagoon on our passage to the Isle of France. I am glad we have visited these islands. Such formations surely rank high amongst the wonderful objects of this world. Captain Fitzroy found no bottom with a line 7,200 feet in length, at the distance of only 2,200 yards from the shore. Hence this island forms a lofty submarine mountain, with sides steeper even than those of the most abrupt volcanic cone. The saucer-shaped summit is nearly 10 miles across, and every single atom, from the least particle to the largest fragment of rock in this great pile, which, however, is small compared with very many other lagoon islands, bears the stamp of having been subjected to organic arrangement. Footnote 10. I exclude, of course, some soil which has been imported here in vessels from Malacca and Java, and likewise some small fragments of pumice drifted here by the waves. The one block of greenstone, moreover, on the northern island, must be excepted. We feel surprise when travelers tell us of the vast dimensions of the pyramids and other great ruins, but how utterly insignificant are the greatest of these when compared to these mountains of stone accumulated by the agency of various minute and tender animals. This is a wonder which does not at first strike the eye of the body, but after reflection, the eye of reason. I will now give a very brief account of the three great classes of coral reefs, namely atolls, barrier, and fringing reefs, and will explain my views on their formation. Footnote 11. These were first read before the Geological Society in May 1837, and have since been developed in a separate volume on the structure and distribution of coral reefs. Almost every voyager who has crossed the Pacific has expressed his unbounded astonishment at the lagoon islands, or, as I shall for the future call them by their Indian name of atolls, and has attempted some explanation. Even as long ago as the year 1605, Pirard de Laval well exclaimed, "C'est une merveille de voir chacun de ces atollons, environ d'un grand banc de pierre tout autour, n'y ayant point d'artifice humain." The accompanying sketch of Whitsunday Island in the Pacific, copied from Captain Beechey's admirable Voyage, gives but a faint idea of the singular aspect of an atoll. It is one of the smallest size, and has its narrow islets united together in a ring. The immensity of the ocean, the fury of the breakers, contrasted with the lowness of the land and the smoothness of the bright green water within the lagoon, can hardly be imagined without having been seen. The earlier voyagers fancied that the coral-building animals instinctively built up their great circles to afford themselves protection in the inner parts, but so far is this from the truth, that those massive kinds, to whose growth on the exposed outer shores the very existence of the reef depends, cannot live within the lagoon, where other delicately branching kinds flourish. Moreover, on this view, many species of distinct genera and families are supposed to combine for one end, and of such a combination not a single instance can be found in the whole of nature. The theory that has been most generally received is that the atolls are based on submarine craters, but when we consider the form and size of some, the number, proximity, and relative positions of others, this idea loses its plausible character. Thus, Suadiva Atoll is 44 geographical miles in diameter in one line, by 34 miles in another line. Rimsky is 54 by 20 miles across, and it has a strangely sinuous margin. Bow Atoll is 30 miles long, and on an average only 6 in width. Menchikoff Atoll consists of 3 atolls, united or tied together. This theory, moreover, is totally inapplicable to the northern Maldiva atolls in the Indian Ocean, one of which is 88 miles in length and between 10 and 20 in breadth. For they are not bounded like ordinary atolls by narrow reefs, but by a vast number of separate little atolls, other little atolls rising out of the great central lagoon-like spaces. A third and better theory was advanced by Chamisso, who thought that from the corals growing more vigorously where exposed to the open sea, as undoubtedly is the case, the outer edges would grow up from the general foundation before any other part, and that this would account for the ring or cup-shaped structure. But we shall immediately see that in this, as well as in the crater theory, a most important consideration has been overlooked, namely, on what have the reef-building corals, which cannot live at a great depth, based their massive structures. Numerous soundings were carefully taken by Captain Fitzroy on the steep outside of Keeling Atoll, and was found that within 10 fathoms the prepared tallow at the bottom of the lead invariably came up marked with the impression of living corals, but as perfectly clean as if it had been dropped on a carpet of turf. As the depth increased, the impressions became less numerous, but the adhering particles of sand more and more numerous, until at last it was evident that the bottom consisted of a smooth sandy layer. To carry on the analogy of the turf, the blades of grass grew thinner and thinner, till at last the soil was so sterile that nothing sprang from it. From these observations, confirmed by many others, it may be safely inferred that the utmost depth at which corals can construct reefs is between 20 and 30 fathoms. Now, there are enormous areas in the Pacific and Indian Ocean in which every single island is of coral formation, and is raised only to that height to which the waves can throw up fragments and the winds pile up sand. Thus, Radak group of atolls is an irregular square, 520 miles long and 240 broad. The Low archipelago is elliptic formed, 840 miles in its longer and 420 in its shorter axis. There are other small groups and single low islands between these two archipelagos, making a linear space of ocean actually more than 4,000 miles in length, in which not one single island rises above the specified height. Again, in the Indian Ocean, there is a space of ocean 1,500 miles in length, including 3 archipelagos, in which every island is low and of coral formation. From the fact of the reef-building corals not living at great depths, it is absolutely certain that throughout these vast areas, wherever there is now an atoll, a foundation must have originally existed within a depth of from 20 to 30 fathoms from the surface. It is improbable in the highest degree that broad, lofty, isolated, steep-sided banks of sediment, arranged in groups and lines hundreds of leagues in length, could have been deposited in the central and profoundest parts of the Pacific and Indian Oceans, at an immense distance from any continent, and where the water is perfectly limpid. It is equally improbable that the elevatory forces should have uplifted throughout the above vast areas innumerable great rocky banks within 20 to 30 fathoms, or 120 to 180 feet, of the surface of the sea, and not one single point above that level. For where on the whole surface of the globe can we find a single chain of mountains, even a few hundred miles in length, with their many summits rising within a few feet of a given level, and not one pinnacle above it? If then the foundations whence the atoll-building corals sprang were not formed of sediment, and if they were not lifted up to the required level, they must of necessity have subsided into it. And this at once solves the difficulty, for as mountain after mountain and island after island slowly sank beneath the water, fresh bases would be successively afforded for the growth of the corals. It is impossible here to enter into all the necessary details, but I venture to defy anyone to explain in any other manner how it is possible that numerous islands should be distributed throughout vast areas, all the islands being low, all being built of corals, absolutely requiring a foundation within a limited depth from the surface. Footnote 12. It is remarkable that Mr. Lyell, even in his first edition of his Principles of Geology, inferred that the amount of subsidence in the Pacific must have exceeded that of elevation, from the area of land being very small relatively to the agents there tending to form it, namely, the growth of coral and volcanic action. Before explaining how atoll-formed reefs acquire their peculiar structure, we must turn to the second great class, namely barrier reefs. These either extend in straight lines in front of the shores of a continent or of a large island, or they encircle smaller islands, in both cases being separated from the land by a broad and rather deep channel of water, analogous to the lagoon within an atoll. It is remarkable how little attention has been paid to encircling barrier reefs, yet they are truly wonderful structures. The following sketch represents part of the barrier encircling the island of Bola Bola in the Pacific, as seen from one of the central peaks. In this instance, the whole line of reef has been converted into land, but usually a snow-white line of great breakers, with only here and there a single low islet crowned with coconut trees, divides the dark heaving waters of the ocean from the light green expanse of the lagoon channel. And the quiet waters of this channel generally bathe a fringe of low alluvial soil, loaded with the most beautiful productions of the tropics, and lying at the foot of the wild, abrupt central mountains. Encircling barrier reefs are of all sizes, from 3 miles to no less than 44 miles in diameter, and that which fronts one side and encircles both ends of New Caledonia is 400 miles long. Each reef includes one, two, or several rocky islands of various heights, and in one instance even as many as 12 separate islands. The reef runs at a greater or lesser distance from the included land, in the Society Archipelago generally from 1 to 3 or 4 miles, but at Hogoleu the reef is 20 miles on the southern side and 14 miles on the opposite or northern side from the included islands. The depth within the lagoon channel also varies much, from 10 to 30 fathoms may be taken as an average, but at Vanikoro there are spaces no less than 56 fathoms, or 363 feet deep. Internally, the reef either slopes gently into the lagoon channel or ends in a perpendicular wall, sometimes between 200 and 300 feet underwater in height. Externally, the reef rises like an atoll with extreme abruptness out of the profound depths of the ocean. What can be more singular than these structures? We see an island which may be compared to a castle situated on the summit of a lofty submarine mountain, protected by a great wall of coral rock, always steep externally and sometimes internally, with a broad level summit, here and there breached by a narrow gateway through which the largest ships can enter the wide and deep encircling moat. As far as the actual reef of coral is concerned, there is not the smallest difference in general size, outline, grouping, and even in quite trifling details of structure between a barrier and an atoll. The geographer Balby has well remarked that an encircled island is an atoll with high land rising out of its lagoon. Remove the land from within, and a perfect atoll is left. But what has caused these reefs to spring up at such great distances from the shores of the included islands? It cannot be that the corals will not grow close to the land, for the shores within the lagoon channel, when not surrounded by alluvial soil, are often fringed by living reefs. And we shall presently see that there is a whole class, which I have called fringing reefs, from their close attachment to the shores both of continents and of islands. Again, on what have the reef-building corals, which cannot live at great depths, based their encircling structures? This is a great apparent difficulty, analogous to that in the case of atolls, which has generally been overlooked. It will be perceived more clearly by inspecting the following sections, which are real ones, taken in north and south lines, through the islands with their barrier reefs of Vanikoro, Gambier, and Maurua, and they are laid down both vertically and horizontally on the same scale of 1/4 of an inch to a mile. It should be observed that these sections might have been taken in any direction through these islands, or through many other encircled islands, and the general features would have been the same. Now, bearing in mind that the reef-building coral cannot live at a greater depth than from 20 to 30 fathoms, and that the scale is so small that the plummets on the right hand show a depth of 200 fathoms, on what are these barrier reefs based? Are we to suppose that each island is surrounded by a collar-like submarine ledge of rock, or by a great bank of sediment ending abruptly where the reef ends? If the sea had formerly eaten deeply into the islands before they were protected by the reefs, thus having left a shallow ledge round them under water, the present shores would have been invariably bounded by great precipices, but this is most rarely the case. Moreover, on this notion, it is not possible to explain why the coral should have sprung up like a wall from the extreme outer margin of the ledge, often leaving a broad space of water within, too deep for the growth of corals. The accumulation of a wide bank of sediment all round these islands, and generally widest where the included islands are smallest, is highly improbable, considering their exposed positions in the central and deepest parts of the ocean. In the case of the barrier reef of New Caledonia, which extends for 150 miles beyond the northern point of the islands, in the same straight line with which it fronts the west coast, it is hardly possible to believe that a bank of sediment could thus have been straightly deposited in front of a lofty island, and so far beyond its termination in the open sea. Finally, if we look to other oceanic islands of about the same height and of similar geological constitution, but not encircled by coral reefs, we may in vain search for so trifling a circumambient depth as 300 fathoms, except quite near to their shores. For usually land that rises abruptly out of water, as do most of the encircled and non-encircled oceanic islands, plunges abruptly under it. On what, then, I repeat, are these barrier reefs based? Why, with their wide and deep moat-like channels, do they stand so far from the included land? We shall soon see how easily these difficulties disappear. We come now to our third class of fringing reefs, which will require a very short notice. Where the land slopes abruptly under water, these reefs are only a few yards in width, forming a mere ribbon or fringe round the shores. Where the land slopes gently under the water, the reef extends further, sometimes even as much as a mile from the land, but in such cases the soundings outside the reef always show that the submarine prolongation of the land is gently inclined. In fact, the reefs extend only to that distance from the shore at which a foundation within the requisite depth from 20 to 30 fathoms is found. As far as the actual reef is concerned, there is no essential difference between it and that forming a barrier or an atoll. It is, however, generally of less width, and consequently few islets have been formed on it. From the corals growing more vigorously on the outside, and from the noxious effect of the sediment washed inwards, the outer edge of the reef is the highest part, and between it and the land there is generally a shallow sandy channel a few feet in depth. Where banks or sediments have accumulated near to the surface, as in parts of the West Indies, they sometimes become fringed with corals, and hence in some degree resemble lagoon islands or atolls, in the same manner as fringing reefs surrounding gently sloping islands in some degree resemble barrier reefs. End of Chapter 20, Part 2. Recording by Joseph Ugaretz, Brooklyn, New York, www.mountebank.org.